If you are building a Node.js application and thinking about deployment, you're in the right place. In this video, we will walk through how to Dockerize your Node.js application and test the image locally using Docker Compose. Whether you are deploying your app to containers, running app on a virtual instance, or even hosting small services on Lambda, one tool stays constant: Docker. It's a powerful way to build consistent portable environments across all stages of development and deployment. Hi, my name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. I usually deploy my applications in three ways. The first one is using ECS containers fronted with a load balancer for scalability. This is an enterprise-level deployment meant for high traffic. Together with a database, it can cost a little bit of money, so I normally do it for projects at work. The second way is deploying an application using Docker Compose on a virtual server, for example, EC2 instance. This may not seem to be cheap at first, but if you manage to deploy 4 or 5 applications on the same server, front them with an Nginx reverse proxy, and use free Let's Encrypt certificates, this becomes a pretty cheap option for your pet projects. Finally, I sometimes use Lambda with a Lambda function URL. Usually I do it for small internal services that don't get much traffic or an internal API documentation such as Swagger. The common denominator in all of these deployments is Docker. Let's take a look at how we can Dockerize the Node.js Express Task Manager API that we have been building. As usual, the link to the GitHub repo with the code is in the description below. So, what is Docker? Docker is an open source platform that enables developers to automate the deployment, scaling, and management of application using containerization. A container is a lightweight, standalone, and executable package that includes everything needed to run a piece of software, code, runtime, libraries, and dependencies, so it works reliably across different computing environments. Unlike traditional virtual machines, containers share the host system's operating system, making them more efficient and faster to start. With Docker, you can ensure consistent environments. Docker also integrates seamlessly with modern CI/CD pipelines, cloud platforms, and orchestration tools like Kubernetes. This makes it ideal for building microservices, architectures, testing distributed systems, and simplifying the software delivery process. With a little bit of a background on Docker, let's start Dockerizing our application. The first thing I do is I create a .dockerignore file. You put in this file all the stuff from your project that are not needed for the deployment. Let's create that .dockerignore file in the root of our project. In this file, we'll put the following content: node modules, dist, .env, .env.example, .vscode, .git, .github, and .husky. We kind of need node modules and dist folders to run our application. However, we will be installing dependencies and building the application in a Docker container, so we won't need the ones that we have in the project. The next file that we create in the root of our project is Dockerfile with a capital D. If you are using VS Code, you may want to install Docker plugin for VS Code. We will be building our image based on Node.22 Alpine image. It is a small image that contains only essential stuff. At the time of recording, Node.22 is a long-term support version. Depending on when you are watching this, you may want to use a different Node version. I also like to use multi-stage builds for my Docker images. Therefore, the first stage will be a builder stage. Multi-stage builds allow you to separate different parts of the build process into distinct stages. For example, one stage builder can handle compiling or building your app, and another installer or runner can create a slim final image by copying only the necessary artifacts, reducing image size, and improving security. APK is a package manager for Node Alpine similar to NPM. We will use it to install libc6 compact library. This is a shared library that may be needed, so it's better to install it. Next, we will set working directory as app and copy all the files into it. That's when Docker will ignore files that we specified in Dockerignore. We will run npm install and npm run build. Now let's create installer stage. We will use Node.22 Alpine as installer. Besides installing libc6 compact, we will also install OpenSSL. This library will be needed for Prisma. Again, we set working directory as app. We will copy only specific files from the builder stage, dist and Prisma folders, and package.json and package log.json. We will run npm CI. CI stands for clean install. It uses package log.json exactly as it is to install the dependencies and also removes node modules folder if it is present before running the install. We will also use omit equals dev flag to not install dev dependencies. We already used dev dependencies to build our project in the previous stage and don't need them anymore. If you don't separate your dev and prod dependencies when working on a project, you may not want to use this flag. Finally, we will run Prisma generate to generate Prisma client. Now we will create the last stage, the runner stage. As in the previous stages, we will install dependencies with APK with set app as the working directory. Not running production as a root also applies to images. We will set a group and a user called express.js. This user will be running the app. Then we will copy the app folder from the installer stage and do cmd npm run docker start. It is important to put the parts of the npm run docker start as an array instead of the actual command. Our Dockerfile is complete. Let's go ahead and create the docker start script in package.json. But before we do that, if you're learning something new, please hit the like button and subscribe to our channel for more videos like this. Docker start script needs to do two things: run migrations and start the application. We have scripts for both of these tasks, therefore we can combine them together with npm run migrate and npm run start. The final step that I do before deploying my application is test it locally. In our case, all I care is that the app actually connects to the database, runs migrations, and starts up. So we will need to deploy the API and the database locally. The easiest way to do this is with a Docker Compose. Also, to be able to run Docker on your local machine, you will need to install it. I use Docker Desktop, so I suggest installing that if you don't already have it installed. Let's create Docker Compose YAML file in the root of our project. We will define version 3.8. There will be two services. One of them is app. It will be built from the current folder using Dockerfile named Dockerfile. Minimally, to test the app, we will need only database URL and Node.env environment variable. Docker Compose is a great way to test an API in production-like environment. If you want to test other features such as authentication, feel free to add more environment variables. Also, please note that in the context of Docker Compose, the database server is not localhost anymore, but DB. This is how our database service will be called. We will define it in a little bit. We will also specify that app service depends on a database service and map port 3000 of Docker container to the port 3000 on local machine. Next, let's define database service. We will call it DB. We will use MySQL 8.0 image. In the environment, we will put password, secret, and MySQL database task manager. We will also map the port 3306 in the database Docker container to 33061 on the local machine. 3306 is the port that MySQL runs on in the container. On the local machine, I already have port 3306 taken by MySQL development database, so I'm using the port 33061. Database will need to store data. Let's map DB data volume to varlib MySQL. Finally, we will define DB data volume under the volume section. And we're all set. Let's start up Docker Compose with a command docker compose up-d. -d means Docker Compose will be running in a detached mode. It may take some time for Docker Compose to start up, because first it will download the image for MySQL 8.0 and set up the database, then it will build an app, and finally it will deploy the Docker containers. After the Docker is deployed, we can go to Docker Desktop. We can see that only one of the containers is running. Let's expand Node and Express.js app and click on View Details for App Container. We can see that there is an error. P1001 can reach database server at DB 3306. This happened because Docker Compose had to set up the database task manager, so our app tried to connect to it before it was ready. Setting up the database is a one-time process. Let's stop Docker Compose with the command docker compose down, and then start it again with docker compose up-d. When we go and view details for the container again, we can see that the app connected to the database and migrations ran successfully. However, we have permission issue creating logs directory. We're trying to create logs directory for Winston file logger. Creating logs inside the Docker container is not a good idea. They are hard to access and will bloat your container. Normally, you would send your logs to a log service or use a cloud logging service such as CloudWatch. By the way, if you would like to learn more about CloudWatch on AWS, please check out this video. Let's go ahead and bring down Docker Compose. We will go into src logger.cs file and comment out the file transport logger code. Since we made updates to our code, we will need to rebuild the app. We can do it with a command docker compose up-d with a build flag. Now, if we go to Docker desktop, we can see both containers are running. Since we bounded our app container to port 3000 on our local machine, we can now do a quick test by making a GET request to the health endpoint of our application. And we can see that the application is responding. Everything is working. Finally, if you're happy how the application works on your local machine and you don't need the images and volumes that Docker Compose created, you can run command docker compose down -rmi all -volumes. This will stop and remove containers, remove all images defined in the Docker Compose file, and remove attached volumes. And this wraps up the workflow you can use to Dockerize your application and test it locally. Now you can deploy your application the way you like it. If you would like to learn how to deploy your application to an ECS container on AWS, please watch this video next.